Okay, guys, we're going to pick up with number 9. 1 through 8 is on the previous video. So number 9 today, and we'll get through as many as we can in about 10 minutes, and then I'll pause it and I'll pick up with the next one, and we'll get through all 50. So if you have a question, you can check them out. Number 9 says, if f of x is x plus 5 and g of x is x minus 4, find f plus g of negative 4. The easiest way to do that is to find f of negative 4 and find g of negative 4 and add those two results together. All right, so if I plug negative 4 into x for the f equation, it'd be negative 4 plus 5, which is 1. And if I plug negative 4 into the g equation, it'd be negative 4 minus 4, which is negative 8. So what I need to do is add 1 plus negative 8, which is negative 7. So my answer is B. Number 10. Number 10 wants me to do f minus g of negative 3. So I'm going to do f of negative 3, get an answer, do g of negative 3, get an answer, and subtract those two. F of negative 3 minus g of negative 3. All right, you've got to be careful here because you've got a squared. So when you square a negative, you want to make sure that you actually square the negative and the number. So it'd be negative 2 times negative 3 squared plus 7, if I plug into the f equation, which would be negative 2 times 9 plus 7, which is negative 18 plus 7, which is negative 11. And then for g of negative 3, that'd be negative 3 minus 4. Negative 3 is going to be my x, so negative 3 minus 4 is negative 7. So what I need to do is I need to do negative 11 minus negative 7. Negative 11 minus negative 7 is negative 4. So my answer is D. Number 11, find f divided by g of negative 4. So I want to do f of negative 4, and I want to do g of negative 4, and then I want to divide those two. So f of negative 4 means plug negative 4 into the f equation. 4 times negative 4 minus 5 is negative 16 minus 5. That's negative 21. And then g of negative 4 is 3 times negative 4 squared plus 14 times negative 4 plus 2. I'm plugging in negative 4 everywhere there's an x in the g of x equation. So that's 3 times negative 4 squared is 16 plus 14 times negative 4 would be negative 56 plus 2. 3 times 16 is 48 plus negative 56 plus 2, that'd be negative 8 plus 2 is negative 6. So it would be negative 21 divided by negative 6, which reduces to, let's see, the negatives will cancel. And 3 would go into the top and the bottom. 3 goes in the top 7 times. 3 goes in the bottom 2 times. So 21 over 6 reduces to 7 halves. So my answer is A. Number 12, f minus g of x. Now this time I'm just plugging in x for x, and it's already there. So basically it's going to be f, which is 8x minus 2, minus g, which is 5x minus 9. And the only thing you have to remember is that if you subtract an expression, you have to subtract both parts of it. So this would be minus 5x, and then I'm going to subtract a minus 9, which would make that plus 9. So combine your like terms. 8x minus 5x is 3x, and negative 2 plus 9 is plus 7. 3x plus 7, your answer is C. Number 13, f divided by g of x. The division ones are probably the easiest one. F would go on top, so 4x minus 7 goes on top, and g goes on the bottom, so 9x minus 5 is on the bottom, and that is your answer. It doesn't simplify at all, so that's as easy as it gets. All right, number 14, find the domain of f plus g. Okay, just a review on domain. Domain is all real numbers unless, one, you have a denominator. We've talked about it. We talked about it in every class today. Denominator can't equal 0. And then 2, if you have a square root or an even root, you can't have a negative underneath the root. So here, if I'm going to add f and g, I would add 2x minus 5 plus the square root of x plus 10. They want to know what is the domain. Let me show you how you can see it on your calculator. I'm going to go over to y equals, and in y equals, I'm going to just type that. 2x minus 5 plus the square root of Was it x minus 10 or x plus 10? X plus 10. X plus 10. When they say what's the domain, that means what can x be? So let me go to the table and see what x can be here. Looks like it's working everywhere here. Let's keep scrolling up a little bit here. Oh, what's happening there? Error, error, error. So that means, looks like when I go less than negative 10, I keep getting errors. I can check it the other way and see what happens. But what happens is you can't have a negative underneath this radical. So x plus 10 has to be greater than or equal to 0 because I can't do the square root of negative 1. That's an imaginary number. So if x plus 10 has to be greater than or equal to 0, then x has to be greater than or equal to negative 10. I subtract 10 from both sides here. So the way that that looks as one of these answers is we're talking about x has to be greater than or equal to negative 10. So this is my answer. In an interval notation, that would be from negative 10 to infinity. And I'd put a bracket at negative 10 because it can equal negative 10. I can do the square root of 0. So I plugged in negative 10, it'd be negative 10 plus 10, which is 0. I can do the square root of 0. I can't divide by 0. But anything larger than negative 10 will work. All right, number 15, find the domain of f plus g. When you're adding numbers, I'm going to change the colors here so you can see what I'm doing. When you're adding two graphs together, or subtracting or multiplying or dividing, you look at where they're overlapping. I cannot add f and g when x is negative 3 because there's not a g to add to the f. I can't do it at negative 2 either, but I can do it at negative 1. And all the way until I get to 3. I can add these two functions together. I can't go to 4 because while I have a g, I don't have an f to add to it. So my domain for f plus g is negative 1 plus 3. I can add 0 plus 1 and get an answer. I can add 1 plus 2 and get an answer. I can add 2 plus 3 and get an answer. I can add 0 plus 2 and get an answer. And I can add negative 1 plus 1 to get an answer. But out here, I can't get an answer. There's nothing to add to 4. And same thing here. There will be nothing to add with negative 1 and nothing to add with negative 2. All right, find the domain of f divided by g. Again, I can't divide if I don't have both of them. So here I can't divide, here I can't divide. Can I divide here? Can you do 0 divided by 1? 0 divided by 1 equals 0. Yep. Can I divide here? It's f divided by g. So can I do 1 divided by 2? Yep, that's 1/2 or 0.5, so that's fine. What about here? Can I do 3 divided by 2? Yes, that's 1.5. What about here? F divided by g would be 2 divided by 0. Can I do 2 divided by 0? No, you cannot divide by 0. So there's going to be a hole in this graph. And then come over here. Can I do f divided by g would be 1 divided by negative 1? Yes, I get negative 1. And I can't go any farther because there's nothing to divide over there. So I want to go from negative 1 to 3, but it can't be at 2. So how do I write that? I say from negative 1 to 2 with a parentheses, and then from 2 to 3, indicating that it's everything between negative 1 and 3 except for it can't be 2. All right, number 17, find the domain of f minus g. Well, that's just going to be x squared minus 9 minus 2x plus 3. I'm just subtracting here, which is combining like terms, and I don't really even have to complete this. There is no denominator. There's no square root, and when there's not a denominator and not a square root, my domain is all real numbers, negative infinity to positive infinity. See if I can do one more before I pause this. Find the domain of f divided by g. This is going to be a little bit longer. So this will be f is on the top, g is on the bottom. Now typically, if it's underneath a square root, it has to be greater than or equal to 0. But because this is on the bottom, it cannot equal 0. So x plus 6 has to be greater than 0. Cannot be equal to, because then you'd be dividing by 0. So x has to be greater than negative 6. So that's going to be from negative 6 to infinity. So when I have a square root on the bottom, I have to worry about two things. The denominator can't equal 0, and it also can't be negative underneath the square root. So that's why I had to put greater than 0 instead of greater than or equal to, because it cannot equal 0. All right, let me pause this right here, and I will pick back up with number 19.